Hello everyone, I'm Nansumba Mary Vanessa presenting a taxpayer prediction project in AI. The contents of my presentation will include explanatory data analysis, data cleaning, Haversine distance, heat maps, correlations, outliers, illustrations of trends in time, box plots, splitting of the data into three, that's test, evaluation, and training, fitting of the model, tuning of hyperparameters, and evaluation of my model. Explanatory data analysis. What does this mean? This refers to the critical process of performing initial investigations on the data so as to discover patterns, spot anomalies, test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. What's the importance of explanatory data analysis? This helps us to simply comprehend the structure of our data set and making data modeling easy. The primary goal of explanatory data analysis is to make clean data, and it helps us to make our data free of redundancies. Redundancies can be like duplicates or over repeating ourselves. I'm performing explanatory data analysis on my data set to make findings on it. This will help me to build a model on a data set which has been well examined. Next, we have data cleaning. Here, I check for a number of things which may include uniqueness of values in the data set. As we can see here, checking for missing values, but all the values in my data set are there. And we can also check for duplicates. We can check for the nature of the data I'm using. Then when we go to Haversine distance, this helps us to calculate the distance between the pickup and the drop-off points. The difference between the pickup and the drop-off points will give an idea about the distances covered, which should be the most predictive feature for our tax fare. The Haversine formula determines the great circle distance between the 2 points, which are the pickup and the drop-off point. Yeah, on a sphere given their longitudes and latitudes. The Haversine distance uses various libraries, which we shall know. Yeah, when we talk about heat maps for our data set, a heat map is a visualization technique that shows the magnitude of a data heat map is a data visualization technique that shows the magnitude of a phenomenon as a color in 2 dimensions. When you look at the illustration I have here for a tax fare prediction, you are seeing different colors being illustrated. We have orange and some brown in our heat map. For the correlation heat map, it is clear that the distance, longitude, and the latitude features have the higher correlation with the target as compared to other features. Then we talk about the correlation matrix. A correlation matrix is a table that shows the correlation coefficients for various variables. Below is a correlation matrix for our data set with variables such as fare, drop-off, the Haversine distance, and others. Then we talk about the outliers. Then what's an outlier? An outlier is a value that lies between the extremes. So when you see what we have this here, it shows an outlier of the Haversine distance against density, and it shows that the curve only passes through the extremes of the data of what we plotted on our graph. Then we have box plot. A box plot is a standardized way of demonstrating the locality spread and skewness groups of numerical data through their quartiles. There can be lines extending from the box indicating the variability outside the upper and lower quartiles. Box plots are used to show the distribution of numerical data values, especially when you want to compare them between multiple groups. Here we can see clearly our box plots, and we see some data extending, some lines extending from the box. Then here, if we are seeing illustrations of trends in time, On the first one, we have weekly variations of the total number of pickups, and on our observations, we have different things. Here I can see the number of pickups on Saturday and Mondays are much lower than other days with a peak on Saturday. Monthly plot shows significant variations towards the end of the month. Yeah, these show us, give us some analysis on our on how to predict our fares. Then splitting of data into three. Here, when we talk about splitting, we are dividing our data into three forms. That's the train, test, and validation. The train set of the data will be used to train our model to be able to achieve our primary goal of fair prediction. So for our case, we gave it 60%. Then the test set, this will be useful in testing whether our trained model can predict the fares given other features. So we shall feed our model with another data that we didn't train it with to see if it can really predict, and we gave it 20%. Then the validation test will be useful in evaluating our model to check for the accuracy errors and the variance score, and we gave it 20% also. Then training and fitting of the model. Training means the process of increasing the knowledge and skills for a model for doing a particular test. For our project, we used the train set, which is part of the initial data set, to train our data to predict the tax fare. As we said in the previous slide, we gave it, let me see, what is this? The train, we gave train, I think 60. Sorry. Yeah, the train set, we gave it 60. So here we are training our data to predict the fares. Then we go to the evaluation of our model. Evaluation refers to the process of confirming that the model achieves its intended goal. If we have made a model that predicts fares, does it really predict the fares? So here we evaluated our model on the evaluation test, which was 60, and these were our scores. We really did well. Please like, comment on this video. Thank you very much.